Hello everyone and welcome to this video. Today we want to start a very important topic, which is like how to implement row and column operations on matrices. What is the goal? What is the target? By using this row and column operations, we want to solve the system of linear equations. Like you have a question like consider the system of linear equations, and when you want to solve it, eventually it means you want to find the value of x, y and z, the value of the variables. Three equations, so three variables. So how we can use matrices to solve these linear equations? To understand it, first we have to see the rules of row and column operations. Let's take row operations first. When we say row operations, what are the three possible rules? First rule is that you have the two rows, you can interchange them. Like you have a matrix A, B, C, D, E, F, G, H and I. You have this. To get your goal, to get the goal, what is the goal? I will tell you. What's the first rule you can do? You can interchange the two rows. Like you can swap this position, this row with this row. You can write it like D, E, F, A, B, C here. This is the first rule. Second rule is multiplying a row by a non-zero number. Like you have, like this is row 1, you multiply it with 2, so it becomes 2r1, so it will be like 2a, 2b, 2c. What's the third rule? Third rule says adding a multiple of one row to another row. Like you can do it like r2 minus r1. You can make it like 2r2 minus 3r1. This is the third rule to get your target. And what is the target? In row operation, the target is to convert your matrix into an upper triangular matrix. Upper triangular matrix or form. What is this form? Like below the principal diagonal, all of the elements are 0. Below the principal diagonal, all of them are 0. This is your principal diagonal. We have to make sure that below this it's 0. When we convert this matrix by applying row operations into this form, we can get the solution. But for this, we have some steps. Now we have got some introduction to this concept. Now to better understand it, let us solve a question. Because when we will implement the concepts on a question, it will be more clear. So we have this. We have a system of linear equation. Our target is to first find the value of x, y and z. So first we want to write it into matrix form. Matrix form, remember, it is like Ax equals to b. This matrix is the matrix of coefficients, and this matrix was the matrix of the answers. On the right hand side we have like 1, 12 and 3, so this is b, and this is the matrix of variables. So we have constants. We have 1, 1 and 2, the first row, 1, 1 and 2. Second one is 2, minus 1 and 8, 2, minus 1 and 8. This is plus here, yeah, but typing mistake is there. And the third one is 3, 5 and 4. This is the matrix of coefficients. Now matrix of variables. The variables are x, y and z. Sorry, so we have x, y and z here. And now the matrix of the answer, which is 1, 12 and 3. Now to provide the row operations, what we will do, we will merge this matrix with our coefficient matrix, and this matrix is called augmented matrix. What is augmented matrix? We will merge it with our matrix A. How we do it? We have 1, 1, 2. We have 2, minus 1 and 8. We have 3, 5, 4. And we put a dotted line to make the difference, to show the differentiation. We have 1, 12 and minus 3 here. This matrix is called augmented matrix. Now on this matrix we can apply the row operations To convert it into upper triangular form, the target the target is to get this matrix into this form so we can find the values of x, y, and z. This matrix we have to write it in this form, like we have a here, b here, c here. Let's say we have here x, we have here 0, we have here d, e, this is our y, we have 0, 0, f, this is our z. So when we will solve this one, you can say like f equals to z, this is equivalent. Then we have d plus e equals to y, and a plus b plus c equals to x. Okay, now let us start the operations. This is already 1. I'll give you some hints here. This is already 1. Now when this is 1, it makes it easy because I can perform the operations very easily now. Here, if you look at the first row, I don't care for the first row, I can just copy it as it is 1 1 2 1 because I want to make this 0, and I want to make this 0, and I want to make this 0. Okay, now what should I do on R2? This is 2. If I do what? R2 minus 2R1. How about writing this? R2 minus 2R1. So it will give me what? 2 minus 2 into 2 will be 0. Now when you want to do it, it's very easy, but sometimes you can do mistakes. So what's the best way of doing it? On your calculator, put a bracket, minus 2 into bracket. Now every time just take the element of R2 from the second row and take the element of R1 here and place it. Use the replay button to change the values every time. Like the first time you check with this one 2 and put R1 1, your calculator will give you the answer 0. Now next time you want to put here minus 1, this is minus 1, and here it will be 1. So you should try this one. It will give you what answer? It will give you minus 3. Now do the same thing for the third one. It will give you 4, and this one will be 10. This is the best way of doing it. It will not have a chance of mistake. Don't do it manually. Don't do it by like mentally. Just use a calculator, use the replay button. It will save time. Now I need a 0 here, so I can use this 1 as a reference. For example, it was not 1, then we can make it 1 by, like, let's say it is 5 here, so we can do like that, R1 divided by 5, so we can make it 1. If it is 1 here, it makes the question easy, right? Now we have R3 minus 3R1. One more mistake, keep this thing in mind. When you are applying this row operation, the row that is changed is the first one. R3 will change. Nothing will happen to R1. R1 is just helping. So the answer of R3 will change only. Now do the same thing on a calculator. Use this function like minus 3 into R1. Here put the value of R3. Here put the value of R1. So R3 value is 3. R1 value is 1. You will check. Always check from the first operation. It should be 0. Maybe when you are designing this operation, you may have a sign mistake. So it's always better to check. So when you check this, it is 0. Now put here what? 5. Here will be 5, and here will be 1. When you perform this, the calculator will give you what? 5 minus 3, it is 2. Now 4 and 2, it will give you minus 2, and minus 3 and 1 give you minus 6. So we have achieved somehow very close to our target. Now next thing we want to keep it in mind is that we have to convert this 2 into 0. If we can convert this 2 into 0, we are done. We are done with our question. Now here you have multiple options. You have a lot of options in this case now. One, you can swap the rows also if you want, because it is also a part of row operation. Like we can swap the rows. I personally don't like to swap if I can solve it. Like if you see, our target is to make it 0. This is already 0, this is already 0. So if I perform a row operation on these two rows, it will not make any difference. Why? Because 0 and 0, so it will not make any difference. 0 plus 0 will be 0. Even if you multiply, it will be 0. So I can use this to my advantage. I can just copy the first two rows as it is, 1 1 2, and this is 1, this is 0, this is minus 3, this is 4, and this is 10. Now I have to make third row 0. How I can perform an operation so that if 2 minus 3 becomes 0? How if I multiply r3 with minus 3 and r2 with 2? So like I take the coefficients. So what about this? 3r3 minus 2r2. If I do this, see, my target is that here should be 0 and here should be 0. I need a 0 here and I need a 0 here. So if I multiply these two rows, whatever I do, it will be 0. So I will not make any difference here. Let me check if this will give me 0. 3r3. So 3 into 2 minus 2 into minus 3. This is 6. 6 plus 6, it is 12. So what if I do it like plus here? If I do a plus here, it becomes plus. So this will be 6 minus 6 equals to 0. This is one approach. Secondly, you can also do what? You can take common from this one, like 2 minus 2 and minus 6. You can take common also, like you can say like r3 over 2 and shift the rows. There are multiple options. This is one approach, because I am following my target. I need a 0 here, so this operation is giving me 0. So I can apply this one. So on your calculator, don't do it directly on your calculator. See, it's always good to check. If I directly used it and put a 0 here, I will get wrong answer. So always it's good to check if it's giving you 0 or no. So this one will be 0 using this operation. Now replace r3 with minus 2 and r2 with 2. It will give you here a 2, and here you will have another 2. So we are on the target. We got the matrix we wanted. This is a upper triangular form. We have a 0 here, 0 and a 0 here. Now this is representation of z here. So we can say 2z equals to 2. It will give me z equals to 1. It's giving me z equals to 1. Now this one, the second one, it is helping me to find y. So I can say minus 3y plus 4z equals to 10. Minus 3y plus 4z equals to 10. So minus 3y, I have the value of z, plus 4 equals to 10. Minus 3y equals to 6. Y equals to minus 2. I got the value of y also. Now using the first equation, I have 1 plus 1 1 and 2 equal 1. So I can say x plus y plus 2z equals to what? Equals to 1. I have the value of y and z. Let's replace it. X minus 2 plus 2 into 1 equals to 1. So we have x minus 2 plus 2 equals to 1. X value is 1. So we got the answer. Our solution set is